Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from March 28, 2025, Learning to Reason for Long-Form Story Generation. So crafting long, engaging AI stories often relies on hand-designed prompts. This paper proposes a neat alternative, using reinforcement learning, where an AI learns by trying to get rewards. They introduce a reward system called verified rewards via completion likelihood improvement. This allows the AI to learn reasoning from unlabeled book data. Basically, to get better at planning and generating the next chapter of a story, and human evaluators preferred its output. And for those interested in digging into the details, or even trying to replicate this, well, it's great to see they've also released the official code for this research. So in the repository, you'll find all the key components, things like data setup, the reinforcement learning scripts, and also scripts for supervised fine-tuning. Supervised fine-tuning. That's essentially a method to further train an existing AI model on a specific dataset, where you provide it with correct examples to make it better at a particular task. You'll also find tools for story generation and the evaluation code. Pretty comprehensive, actually. Alright, so this first figure, figure 1, shows their training setup. It's for the next chapter prediction task, or NCP, where the AI learns to plan and predict the next story chapter. This uses reinforcement learning with a reward system they call verifiable rewards via completion likelihood improvement, or VRCLI, and an algorithm called GRPO. GRPO. That's an online policy learning algorithm that helps the AI improve its planning. The diagram shows story info going to a policy model, which creates a reasoning trace, a detailed plan. The verifiable rewards via completion likelihood improvement system then rewards this plan if it helps a generator model better predict the actual next chapter. Alright, so moving on from the training setup, figure 2 here shows how the different AI approaches actually stacked up in human evaluations. This uses Bradley-Terry relative strength parameters, which is a method to turn pairwise preferences, like story A is better than story B, into a strength score for each AI model. We see comparisons for the base model, base reasoning, supervised fine-tuning, and the RL-trained model across qualities like plot and creativity. And for both 7B and 3B model sizes, the RL-trained approach, that's the purple bar, generally scores highest, especially with the larger 7B models. Okay, so after seeing those overall human preferences, Table 3 here gives us a more granular look, breaking down performance by story genre. This table shows the mean % improvement, which comes from that verifiable rewards via completion likelihood improvement reward system we discussed earlier. Essentially, how much better the reasoning plan helps in predicting the true next chapter. We see figures for base reasoning, where the reasoning isn't specially trained, and for the RL-trained model. The diff column really shows the added benefit from the reinforcement learning training. For instance, in sci-fi, the RL-trained model shows a 1.00% greater improvement, suggesting this learned reasoning is particularly effective there. Alright, so we've seen how this reinforcement learning approach helps across different genres, and now figure 4 actually gives us a peek at what one of these reasoning traces, these detailed plans, looks like after the AI has been trained. This example is from the QN 2.5 to 7B instruct model. You can see it's a detailed plan for the next chapter, with points like character development for a character named Fern and plot points about witchcraft. The title also notes a 2.58% improvement, which means this particular plan helped the generator model improve its prediction of the actual next chapter by that much, according to that verifiable rewards via completion likelihood improvement system we've been discussing. Seeing that detailed reasoning plan really highlights how this work is pushing towards more controllable, long-form story generation. The key takeaway here is that by training AI models to explicitly reason about the story's future, using reinforcement learning, we can get significantly better and more coherent narratives. This is a big step for creative AI, allowing for more structured and engaging storytelling. Well, that's all for this AI Research Roundup. Thanks for tuning in. I'm Alex.